All right, today we'll be doing proofs. This is the first of 4 notes we'll be doing about proofs, and this is kind of the backbone to everything. We're going to be learning what a proof is, the types there are, and some of the initial reasons for proofs. So let's dive in. The definition of proof is a sequence of valid statements supported with reason that reach a logical conclusion. So what this means is we're going to be having statements. In the beginning, they're going to be very algebraic statements that we're going to give a reason to each one. We're going to learn some of the reasons today. And that have to reach a logical conclusion. So we're looking for something that would make sense, that the logic is in order, and we're going to support it for each one. There are 3 different types of proofs. All right, we have a 2-column proof, we have a flowchart proof, and we have a paragraph proof. Mainly in this class, we will be looking at the first 2, the 2-column and the flowchart. The first one to teach you is 2-column. A 2-column is very clean and organized looking. So those who like structure and order, you're really gonna like the 2-column proof. And then flowchart is a little bit more hectic. It flows from one idea to the next. For me, flowchart is my favorite because I can see where I'm getting the ideas from. It can be a little bit crazy to look at though. So that's why maybe it's not some of our favorites, but we'll learn both of those. And there's paragraph proof, which we won't really learn this year. That's just writing a big paragraph, and I'm sure you and I don't want to write a huge paragraph in a math class right now. So first thing is we know what a postulate is. A postulate is an accepted true statement. So it's something that we just accept as true. An example that we've learned already this year is the segment addition postulate. That's when we add the parts of the segment to make it equal the whole thing. That's an accepted statement. We're good to go. A theorem is one that you can prove. Like the Pythagorean theorem. All right, that's the theorem that we can prove to ourselves and prove to others, and then we can utilize. So what this big table is here, we're going to go through all of the reasons that we would use algebraically today. A lot of these you already know. You've done them in previous math classes. We just didn't have an actual name from them. So I'm going to tell you what it's called. I'm going to show you an example, then we're going to kind of dive in. So the first one, addition, property of equality. I shorthand this one to this, add, POE, property of equality. What this means, if I have an example over here, x minus 5 equals 22. If I was to solve for x, how would you solve for x? You'd add 5 to both sides, so I get x equals 27. So to go from here to here, this step, I added 5 to both sides. Okay, so that would be an example of the addition property of equality. The next one is similar, subtraction property of equality. It's when you would subtract something from both sides. So if this one, I have x plus 3 equals 47. To solve for x, I would subtract 3 from both sides. And I get x equals 44. So to go from one side to the next, I'm subtracting. Up next, we have multiplication property of equality. I do shorthand this one to POE. I don't really shorthand subtraction, just because it's one that starts with an S as well, so that can get confusing. Multiplication, we multiply both sides. Usually this is when we see a fraction, all right? So this one right here, it says x divided by 4 equals 10. To get rid of that fraction, you multiply by 4 on each side. So I get x is 40. And then finally right here, we have the division property of equality. Okay, this one I would divide both sides. So if I have 5x equals 45, to solve for x, I would divide 5 on both sides, and I get x equals 9. Oops. Sorry guys, it's supposed to be a 5 there. All right, so those are all things that you would use to solve an algebra equations. What we know is what we're good at. The rest of them are going to be brand new to us and maybe a little bit more difficult. All right, these are more the geometric ones that we're going to be talking about this year. Change my colors because they're going to be different. All right, up first we have the reflexive property of equality. I just call this reflexive. This is when it equals itself. So my example here says measurement of angle A. Well, the reflexive property means it equals the exact same thing. So I'd say the measurement of angle A. Okay, so it's when it equals itself. Next, we have the symmetric property. Symmetric means it's equal on both sides. Symmetric property means no matter what side of the you can switch around what side of the equal sign it's on. So my example here is I have x equals 8. That could also imply that 8 equals x. So all I did there was flip it. All right, so this flips the order. So what was before the equal sign is now after the equal sign. Okay. Next we have the transitive property of equality. All right, this is when we're going to go from two equations and we're going to merge them into one equation. And here's what I mean. It says the measurement of angle B equals the measurement of angle C, and the measurement of angle C equals 82. I'm going to cross off what they said twice there. So my new equation could be the measurement of angle B equals 82. All right, so this is when you go from two equations that share a commonality there, you're going to condense it down to one. This is a tough one to wrap our head around. People will often get this confused with the next one as well, so we will go over this a ton in class too. Substitution property. This is when you plug in something or you replace something for something else. So I have here x plus y equals 20 and that x equals 8. So since I know what x is, I can plug that in or replace it or substitute it. So instead of that x, I'm going to put 8 plus y equals 20. So substitution is when you plug something in. Okay. Up next we have the distributive property. All right, this is when you distribute through a parenthesis. So you can see our example here. So I have 5 times the quantity, 3x plus 4. So I'm going to distribute that 5 to the terms in the parenthesis. So I'd get 15x plus 20. For people in Mr. English class, we are not going to do the cumulative property. Okay. So those are the properties here. So we have the algebraic ones in the very early on and more of the geometric ones. So we're going to be utilizing these throughout our proofs today. And we're going to be using this whole unit. This is something that I want to have you out on your desk at all times so you can always refer back to it because it's going to be something that we need to keep practicing. So we're going to actually do our first couple proofs here. So like I said, we're going to do 2-column proofs. So this is what a 2-column proof would look like. You would have your statements, right? This is like what you're doing mathematically here. And you're going to have your reasons. Your reasons are going to be one of the reasons that we just learned about on our table here. I will be giving you most of the proofs this year. So I'll tell you this is a 3-step proof. So we're going to have 3 statements to get from our beginning to our end. How proofs work is I'm going to give you a given. All right, so this is what we're starting with. So we're starting with that 3x minus 9 equals 12. And our goal is to prove that x equals 7. So essentially all we're doing here is we're going to solve for x. We're just going to put it into a table form. All right, so when we start this, we're going to put our given statement first. We got to start somewhere. All right, so we're going to start with our equation, 3x minus 9 equals 12. What would you guys do next to solve for x here? I would add 9 to both sides. So I'd have 3x equals 21. I would then divide by 7, divide by 3, and I get x equals 7. You'll notice that what you're trying to prove, right, this is always going to be your very last statement. Okay. And your given is usually your first or within the first couple statements as well. You got to show us where we're starting. So that's our algebra. We can all do that left side, no problem. The reasons, we actually have to give us a reason. So our first statement was we had 3x minus 9 equals 12. Well, where did we get that information from? We got it from the given. So our reason is given. I gave you that information. I gave you that starting point. Okay. And then you're going to look at how you went from step to step. So how did we get to step 2? What did we do in step 1 to get to step 2? Well, to go from those 2 steps, we added 9. So that would be the addition property of equality. And then what did we do to get from steps 2 to step 3? Well, we divided on both sides by 3, so with the division. And we've just completed our first proof. So not too bad, okay? You're just explaining to me what you did in each step. Let's do another example here. All right, we've got that our given is 2 times the quantity 3/2 x plus 8 minus 4 equals 30. And our goal is, what we're trying to prove is x equals 6. All right, so we're going to start off our proof by writing in the given. With these algebraic proofs, there's going to be multiple ways you could do them. All right, so if yours doesn't exactly match up with mine, that's not a big deal. That's okay. Okay, and our reason here is given. All right, we know our last statement, the proof is going to be x equals 6, so we know this can go down here. We just got to figure out what we did in between. So I'm looking at this problem is I'm going to solve for x. So I got the x all by itself. I would first add that 4 over to both sides. So I'd be left with 2 times the quantity 3/2 x plus 8 equals 34. Okay, we could do a couple different things here. It's kind of up to us. If you want to, you could distribute that 2 through. So we could say this is 3x okay, so all I did was I distribute that 2 all the way through all those parentheses there. I would say now up next, we're probably going to subtract that 16. And then we got to our last step here is where we got that x equals 6. We got that because we divided by 3 on both sides. So what we're going to do here now is we're actually going to fill out our reasons. All right, so step 2. All right, how did we go from step 1 to step 2 there? What changed about our equation? From step 1 to step 2, we got rid of this -4. We got rid of that by adding 4 to both sides. So I would say this is the addition property of equality. All right, step 2 to step 3. What we did from step 2 to step 3 is we distributed that 2 to both terms in that parentheses. So I would call this the distributive property. From step 3 and 4, let's say we subtracted that 16. So this is the subtraction. And from steps 4 to 5, we divided by 3, so it's the division. All right, and we are done with our second proof. Perfect, perfect, perfect. We're going to do one more here. This is one that I would most likely never make you do completely by yourself here. This is just good to kind of think through some things. So it says over here in our givens, we're actually given 3 different things. The first thing is that we're given that m plus n equals p. We're given that p equals 3r and that m equals n. Our goal is to prove 3r equals 2n. Oof, that's a lot. All right, so we're going to kind of walk through this. I'm going to do the statements first. Then I'm going to see if you guys can maybe do the reasons on your own. All right, so I put in our first 3 statements there. All I did was I took our givens and plopped them in there. Up next, I would say I do m plus n equals 3r. n plus n equals 3r. 2n equals 3r. All right, so I completed that proof, so we're going to kind of do all the reasons and stuff together here. The first 3 statements all have the exact same reason. What is the reason that we have all those? They were given to us, so all 3 of these are given. All right, the fourth statement says m plus n equals 3r. I'm going to look back and I say, well, originally I said that m plus n equals p. But instead of p now, we said 3r. And the reason we did that was because we saw that p actually equals 3r. So instead of putting 3 there, we plugged something else in. All right, if we go back to our table up here, what was the reason when we plugged something in? Substitution was the reason we plugged something in. So I'm going to say this is substitution. All right, from 4 to 5, they look pretty similar to me. The only thing that looks different here from 4 to 5 is instead of that M, I placed N. And I did that because if you look at statement number 3, we know that M and N are the same. So I replace something again. So I call that substitution. All right, this is a new one. If I look from 5 to 6, all I did was I combined my two n's. I had n plus n. That gives me 2n. That's when you're combining like terms, that's what we call simplify. When you combine like terms. So we'll write that down a little bit here. So that's another reason, a new one, simplify. And then from 6 to 7, we're not really doing anything math-wise. It looks like all we did was we flipped which side of the equation it's on. So can you go back to the reasons and figure out which one of those says that you can flip the side of the equation the item's on? Hopefully you went back and you found that it was the symmetric property. Awesome. All right, so it's a little tough for one. All right, we're going to get really good at different ones. But for right now, if you feel confident on examples 1 and 2, we're right where we need to be. There's some other reasons I want to mark down. These are really important. These are ones we're going to be using a ton in the next couple days. The first one here is simplify. So simplify is when you combine like terms. All right, so simplify is when you combine the terms just like we did in step 6 there. The segment addition postulate is when we have a segment A, B, C. We can say that AB plus the length of BC should equal the whole thing of AC. And angle addition postulate is very similar, it's just with angles. So if we have angle ABC, and it has something in the middle, D, I could say that angle ABD plus angle DBC equals the whole angle of AB. Whoops, sorry guys. ABC. All right, we'll go over those again. Big one there is simplify. You're going to see that one a lot. All right, come with questions to class.